Good morning to all of you. We will continue multivariate descriptive statistics. Today we discuss covariance matrix. Our job is what is population covariance matrix and what is sample covariance matrix. I will show you that how these matrices can be derived from the basic observations. And I hope again for the best, because this is a very important issue in the multivariate statistical modeling domain, which is called covariance matrix. And you will see later on the importance of covariance matrix. It is huge. Let us see the next.
Now come to covariance matrix. See, you have to understand it. Now, although things are very simple, but physical meaning of each of the items must be understood. Then only later on we will be talking about covariance matrix. I will not come back to the physical meaning of covariance matrix further. We will simply say covariance matrix. That means you will be able to catch what is covariance matrix immediately. Then only you will be able to relate the discussion that time. Okay. So, we are interested to know covariance matrix. So, let us discuss from population point of view first, that is population covariance matrix. Correct. If I say my x is a random variable univariate case, then if I ask you what is the variance of x, then you will say that it is expected value of x minus mu square. Yes or no? And you have also seen for your discrete case that all x minus mu, or if I find x I minus mu this square, then f x I we are not using now, let it be general case like this. So, that is why I have written all x. And when you go for integration, you write like this plus this x minus mu square f x dx. This is what? This is the variance component, which is sigma square. ठीक. So, now I will do simple alteration. Instead of ax, I will write xj. That means I want to know the variance of xj. Then you will write, it is nothing but you will write xj minus mu j, only j will be the added there everywhere. Then what you will write? You will write sum total of all xj minus mu j square f xj. This is for discrete case. And you write like this, integration minus infinite to plus infinite x j minus mu j square f x j d x j. This is your continuous case. All right. Fine. Now, if this is the case, and if I what is required, that means for j equal to, if you put j equal to 1 to like p in this formulation, whether it is discrete and continuous, when you put j equal to 1, what you get? You will get sigma 1 square. When you put j equal to 2, you get sigma 2 square. So, like this you will get sigma p square. That means the variance component of all the variables coming from this equation. But we have seen that we have p number of variables, and what we are also assuming that these p number of variables are not independent each other. If x 1 is dependent on x 2, or x 1 and x 2 are not independent, what will happen? For example, height versus weight of people, non-zero. So, that means they have correlation, or other way I can say there is a very much, suppose if someone height is more than other one, it is naturally that weight also more naturally, but there are other parameters also which govern that weight, but naturally this is the case. So, when they are not dependent, not independent, they are dependent, then what will happen? That means, when x vary, x 1 vary, x 2 also vary. So, their simultaneous variability is known as, what do you want to say, x 1 and x 2 co-vary. They simultaneously vary. If they co-vary, there is covariance, means association between their realization of the values of x 1 and x 2. Fine. So, now I will write again variance of x j, we have written expected value of x j minus mu j, that square. It is basically what this one, if I just do little manipulation and if I write like this, that there is a formulation called covariance between x j and x k. If I write like this, x j minus mu j into x k minus mu k. You see the similarity between these two. When I am talking about variance of j, I am saying x j minus mu j, that this one I am further writing x j minus mu j and x j minus mu j. That is why the square is coming. That means same variable I am saying that, suppose it is repeating to creating two variables, same on that it x 1 on x 1, that sense if you do like this. So, the covariance is this, as I am saying if x j vary, x k also vary, there is a chance, that is why I am expecting that what is the association between the two, getting me. So, in that case we can again write down, suppose the same formula, that all x j x k x j minus mu j x k minus mu k, what we will write here for probability density function? Can we write that if x k and x j separately, or we will write x j joint probability, getting me? We have to write the joint probability here, and continuous case you have to write like this. It is double integration or here I have written all x j x k simultaneously, that one summation symbol I have given, but otherwise you have to write all x j all x k, all x j all x k. What is the notation for this? We will use the notation for this is sigma j k. Keep in mind, we have used sigma j for standard deviation, sigma jj for variance, and sigma jk for covariance. So, what I am writing here, that this is sigma j k. Now, be careful about the notation now, that sigma j square equal to sigma j j. Later on we will be using sigma j j, sigma 1 1, that is the variance component, which is basically, if I write sigma 1 1, it is sigma 1 square. Then we will be using sigma j k, which is, this is your variance of x j, and this one is covariance between x j and x k. Okay. So, you have sigma j square, you have sigma j k, and you have p number of variables. Can we not find out the population covariance matrix now? We are now in a position to write down the population covariance matrix. As there are p variables, so covariance stands for every 2 variables. So, how many elements will be there? So, let us write down like this. We will create a matrix P cross P. P stands for number of variables. So, that means this is x 1, x 2 like x p, again x 1, x 2 like x p. So, x 1 and x 1, the variability, then when x 1 is varying with x 1, same variability is variance. So, this one will be sigma 1 1. For the second case x 2, this will be sigma 2 2. So, like this, for p variable case x p is sigma p p. This diagonal lines, all the elements in the diagonal lines are variance component, that I am saying this is basically variance component, variance part of the variable that, as I told you, sigma 1 1 equal to sigma 1 square, sigma 2 2 equal to sigma 2 square, like this variance. Then the off diagonal elements will be covariance. So, what will be this? Sigma 1 2, sigma 1 p. Sigma, again I am writing 1 2 instead of 2 1. That what is the assumption we are doing? Sigma j k equal to sigma k j, because jth variable, kth variable, same 2 variables only, but in order we are changing. Then sigma 2 p, like this you will get sigma 1 p, sigma 2 p, this. So, off diagonal elements, these are covariance part, diagonal elements are variance part. These resultant matrix in our class we will be denoting it like capital sigma. So, keep in mind capital sigma whenever we will be using, this is your population covariance matrix. So, population covariance matrix looks like this, the way the same thing here, you see, sigma 1 1, sigma 1 2, sigma 1 j, sigma 1 p, sigma 1 2, sigma 2 2, sigma 2 j 2 p, like this. If there are p variables, there will be p cross p elements, that this that will be p cross p, that will be the size of the matrix. Okay. Now, we require to know sample covariance matrix. Getting me? So, this matrix, this population covariance matrix, sample covariance matrix. very very vital component of multivariate statistics, very very vital. Covariance matrix for population, for the sample. Now come to the sample part. So, sample case we will say sample correlation covariance matrix is S. We will be denoting sample covariance matrix as S. This will also be P cross P matrix. So, my matrix elements I can write like this: S11, S12, like S1P, again S12, S22, S2P, like this S1P, S2P dot 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 SPP. So, these diagonal elements, these are the variance part, and off diagonal element will be the covariance part. Variance and covariance part. How do calculate S11, S12, like this, all the elements of this matrix. So, the general one is here it will be Sjj, and somewhere here may be your Skj will be there, or Sjk. Correct. So, you can go by the same manner, the way you have developed in the univariate case, the variance computation. So, Sjj, what you will do? We have seen that 1 by n minus 1, sum total of I equal to 1 to n. You have written that x, you have written I, then you have written minus mu, that sense, but we will use here, it is basically x bar you have used. Now, j is coming into consideration, we will write like this. You can use mu, but here it is mu is not available, and we will not when you go for in the sample case, we will always write subtract by the sample average. That is why n minus 1 is subtracted. If you use mu here, it will be 1 by n. So, this square, yes or no? Then if I can write this one like this, 1 by n minus 1, sum total of I equal to 1 to n x I j minus x j bar. Again I can write like this, x I j minus x j bar, same thing. So, using this I want to write x j k. X j k is 1 by n minus 1, sum total of I equal to 1 to n. First I will keep the j variable as it is, then second case you introduce k. Correct. What is happening here? Actually, if you see in the covariance case or the variance case, the original data matrix is transformed. That we will capture, that concept we will take here. You see that x I j minus x j bar, that means for the jth variable every element is subtracted by its average. For the kth variable also, every element is subtracted by its average. Now, if this is the case, can I not write down the the data matrix in this format like this, that my original data matrix is X, which is x 11, x 21, x n1, x 12, x 22, x n2, then x 1j, x 2j, x ij, then x nj, x 1p, 2p, then x np. So, you have computed here, this is x 1 bar, x 2 bar, x j bar, x p bar. Then you are writing something, you are converting this, that some conversion is taking place here, that is subtraction of mean. Then what are you getting here? If I subtract by mean, I will be getting every observation is subtracted by its corresponding mean value. Okay. So, if I just after this, basically it is a subtraction by corresponding mean, which is this. So, instead of writing this minus this, if I write like this, suppose I will write x star is like this, x star 1 1, x star 2 1, so like this x star n 1. Same manner I am writing x star 1 p, x star 2 p, like this x star n p, somewhere there will be x star I j, general one, where x star I j is x I j minus x j bar. That means this matrix same. Okay. Now, if I use this formula, what will happen then? In this case, that means x I j minus x j bar is x j star, and this one will be x I k star. So, the resultant matrix will be then 1 by n minus 1 sum total I equal to 1 to n x star I j x star I k. Okay. So, this type of conversion will take place, and ultimately little more mathematics that we will see that. I think up to that you calculate this using this formulation. Using this formulation, can you calculate? You take the first data, this data point you take, the same data point, that first 3 variable values I think I have given you. Suppose this is my data points. You already calculated mean value. You have to now calculate the variance and covariance part, because there are 2 variable, only one covariance will be there. Yeah. Then next class I will go for the matrix, how using matrix multiplication formula we will be able to calculate the covariance matrix totally, then the correlation matrix, all those things. Okay, thank you.